Hi there, folks. Welcome to another calculus video. So this video, we're going to be using our knowledge of integration by parts to integrate something that's a little more difficult than what we're used to. So just a quick refresher on integration by parts. We know that it's used to integrate expressions like this one, where none of our ordinary integral tricks are going to work. And this doesn't really appear on any of the elementary antiderivative tables. So we know that we're going to have to do a little bit of extra effort here so we can integrate it. So we can tell that we have to use integration by parts. We have one function times another function. So that's kind of a giveaway that we have to do integration by parts. So the strategy, I know this isn't the main problem we're focusing on in this lesson, but it's a pretty good refresher, pretty versatile problem for my methods. So we know we want to choose a u and a dv. So we have to be pretty strategic with what we choose to be u and what we choose dv. We can have this be u and then we can have cosine of x be dv, or we can have it the other way around. So as just a quick recapper, we know that a good strategy for picking u would be to take a look at both functions and then decide which one gets simpler the more you take the derivative. So we know that the derivative of x is 1, derivative of 1 is 0. So this one definitely does get simpler, but let's try the other one just so you guys can see this method a little bit more clearly. So the derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is negative sine, so positive sine, and then the derivative of positive sine is just cosine of x. So we're back to where we started. So as you guys can see, this doesn't really get simpler the more we take the derivative. We cycle through a few different values and then we always end up where we started. So this would not be a good choice for you. So we can tell that x is the good choice for you because it gets simpler. And we know we would just write it in this form, uv minus the integral of v du. Then we just plug in our values and integrate. Hopefully it'll be simple enough to integrate so we don't have to do any more iterations. But for this particular problem, notice how none of these really get simpler when you take the derivative. E to the x is a cool function. And I didn't realize how cool it was and how important it was until I got into calculus. We first learn about this function, it's kind of mysterious when you're seeing it for the first time. For the most part, people encounter it for the first time in Algebra 2 or maybe pre-calc. It's the thing that's really cool about it is the fact that it's the only function in the world that you take the derivative of and get itself. The derivative of e to the x is e to the x. So clearly we can see that this one stays the same when we take the derivative. So this, upon first inspection, doesn't really look like a good choice for you. But then let's take a look at the other one, and maybe we'll have better luck. So we know that the derivative of sine of x is cosine, and because I wrote this down a minute or so ago, we don't really need to go through all that again, but clearly you can see that we're going to end up back where we started. We're going to do this derivative a few times, and then we're going to get back to sine of x. So this one doesn't really get simpler either. So you might be thinking that integration by parts might not help us a whole lot here. You might think that we may need more advanced methods. But integration by parts actually does work here, but not in the sense you would expect if you're seeing a problem like this for the first time. So we still want a u and a dv, but as you guys can see, the derivative doesn't really simplify either of these. It doesn't really matter which one you pick to be u and which one you pick to be v. So I think I'm just going to have u be sine of x, and then dv would just be e to the x. So we know how the process works. We have uv, which is sine of x, and then the v would be antiderivative of e to the x, that's just e to the x. And then we have minus the integral v times du. So we're integrating this product. V, of course, is still going to be e to the x, and then du would be cosine of x. So in this one, we want to do another iteration of integration by parts. Because we still have what looks like the result, or part of the result if we were to use the product rule for derivatives. So we know we have a function times another function. It's another integration by parts problem. So we have this right here, and then I'm going to do this once again. We have a u, we have a dv. So this would be u times v. And then minus the integral, make that a little bit neater, integral of v du. So this would be v, and then d would be negative sine. So from here, before we continue, I want to distribute this negative sign. We're going to arrive at this. And then we have plus the integral of e to the x times negative sine of x. And then from here, we want to maybe just move this negative out front. So instead of e to the x times negative sine, I think I'm going to make it just minus the integral of e to the x times positive sine of x. So I'm sure you're thinking by now that this really isn't doing anything. We're just grinding through what seems like pointless effort, and we're getting exactly what we started with. This isn't going to help us at all, but it actually helps us a lot. And I'll show you why. Notice how we have this appearing more than once on the page. We have it appearing right here, but notice how it's also what we started with. This is the function that we began with, the function that we're trying to integrate. So the same thing appears on both sides of the equal sign. One of them is positive, the other is negative. So that being said, I just want to rewrite this expression so that we have it written horizontally with the equal sign. And then this is going to be minus the integral of e times sine of x dx. So because we have this appearing on the same sides of the equation, they're appearing on both sides, I want to add this to both sides. I want to add the integral of e to the x sine of x to both the left and the right. So let's see what happens. So we get 2 times integral of e to the x sine of x equals sine of x times e to the x minus the cosine of x e to the x. And this whole thing just goes away. Let me move things up a little bit. Whoops, missed the integral sign on that one. Doesn't really matter, I guess, because that term has been negated. We have canceled that out with the one above it. So here, let me move this one up a little bit too. All right, so as you guys can see here, we have basically the thing we're trying to solve for in the first place, complete with an antiderivative, but there's just one final thing we have to do. We have to get rid of this 2, and we know we just have to divide everything by 2 to get rid of it. So we get our answer, which is the integral of e to the x sine of x equals 1/2. I'm probably gonna just factor out an e to the x from both of these terms, and also first divide 1/2 by both of these, and then factor out that 1/2. So, sorry, I said divide by 1/2, I meant to say divide by 2. So we're dividing both of these terms by 2, which is the same thing as multiplying by 1/2. which means both of these terms can have 1/2 e to the x factored out, and we get this is our general solution.